All right, so back in section 1.1, analyzing categorical data. Today we're going to look at the second half of this, calculating conditional relative frequencies from a two-way table, using bar graphs to compare distributions of categorical data and describe the nature of an association between two categorical variables. So we're going to start to get the relationship between a couple of categorical variables in a two-way table. So let's see. All right, so marginal and joint relative frequencies don't tell us much about the relationship. Marginal tell us nothing, really. Joint just gives us a little bit how many are in this category and the intersection of those two categories. So if we want to actually start to look at a relationship between variables, we're going to look at conditional relative frequencies. So it's the percent or proportion of individuals that have a specific value for one categorical variable among individuals who share the same of another categorical variable. So, for example, we could ask the question, what percent of environmental club members in the sample are snowmobile owners? All right, so we're just kind of focusing on of the environmental club. So that's our condition, right? So given that condition, so that's who we're going to focus on, is just that column. And then we want to know how many are snowmobile owners. So we're really just kind of limiting it down to these 305 people. Of those 305 people, how many are snowmobile owners? And that, so 16 is the how many, and then if we want to turn it into a relative frequency, percent, we go to 5.2%. So we can see of the environmental club, 5.2% own a snowmobile, all right? And so then we can look at the relationship for other things as well. So the distribution of snowmobile users among the environmental club members is called the conditional distribution. So if we look at not just that one category, but the entire distribution, so remember distribution is the values a variable takes and how frequently it takes those values. So for those people who said yes, we're focusing in on them again, what percent said never used? So that would be 212 out of 305. Or 77 out of 305 for that category, 16 out of 305. And so that in total gives us our entire distribution for that. And so we can kind of keep going on and calculating even more from that. So the non-environmental club members. So we see that distribution for environmental club. Here's our distribution for non-environmental club members, so of that group. So now, and then we can kind of start to compare these and see if they're similar or different. So we see, oh, environmental club members were more likely to, 69% of them were more likely to never have used a snowmobile compared to only 36% of the non-environmental club members. Environmental club members were much less likely to own than the non-environmental club members. And so given those numbers out of this, because and that takes into account the fact that there were many more. If you just compare these numbers straight up without doing percentages, you'll always see, oh, this 445 is bigger than that, 497 is bigger. And that's going to be like misleading because we realized there were 1,221 in the no category and 305. So actually, even though 212 is less than 445, it's a greater proportion. That's why we see this 69%, 69.5% over than this 36.4%. So when you are comparing groups of different sizes, make sure you do use those relative frequencies, percents or proportions, instead of using counts. To make up for the fact that just a bigger sample is going to have more individuals in those categories, or a larger category. Make sure to avoid statements like more club members never use snowmobiles when you mean a greater percentage of club members never use snowmobiles. So it's not actually more. More is the count, even though the count was actually less. If we go back here, it's not environmental clubbers, more of them use snowmobiles. It's actually less, so you're technically wrong. It's a greater proportion of them, or a greater percent of them. So be careful about that when you're making those statements. So we can do a couple of ways of comparing these. We can make a side-by-side bar graph to display both of those conditional distributions and group the bars together. And that's kind of, you stack them side by side in a bar graph. The other option is we can do a segmented bar graph where we can actually split it up vertically, and those are kind of like those ribbon charts I was talking about in the last unit, where you can show those proportions kind of like in a, it's almost like a rectangular, but like pie chart type thing. So here's the side-by-side bar graph. So we can see the distribution for those who said no, the distribution for those who said yes. We have those percentages. So we say, yes, our environmental club members were more likely to have never used snowmobiles. You could also write that down here, but we can also use colors for your key if you don't. But you could have written never under this bar, rent, and own, and then just make sure it's clear that all three of those for yes. So you can kind of compare it that way. Or like I said, you can stack them vertically in a segmented bar graph, where again, this is almost like this rectangle here, this bar here goes up to 100%, and they have shown the percentages. So, you know, this was a little over 20%. This is still covering a little over 20% of that range. And so it's kind of like a pie chart, but they're nice and easy to put next to each other. So we can see, yeah, that green is real thin for the yes group, whereas, you know, the blue was a lot more likely there. And so we kind of see how it's kind of spread out. You know, it's kind of evenly distributed among those, somewhat more evenly distributed. Still, own was the least likely. All right, so if we're looking for an association between two variables, if there's a relationship between them, in other terms, like if there is actually an association between those variables, if knowing one value of one variable helps predict the value of the other. So the fact that these two things are different. If I know if you're an environmental club member, I know that now you're less likely to have owned a snowmobile. Or if you are a not environmental club member, I know that you are more likely to have. And so if these two graphs were the same, that would mean there's no association between these two categorical variables. But the fact that they're different, that means there is a relationship. There is association. So if knowing that you were one or the other did not help, and like I said, if those graphs are the same, that would be a no association situation. So that would be what it would look like. All right, just because there's an association, and this is kind of an old thing you may have heard before. You may have heard it said correlation doesn't apply causation. Well, in this case, we're talking association. I'll get to later why calling it correlation is technically wrong for categorical variables. But association does not necessarily mean that you have a cause-effect relationship between those. So just because there's a relationship here, it doesn't mean being an environmental club member necessarily causes this relationship where you're less likely to. It could be some other variable that affects both, or it could be the reverse. It could be whether or not you like ride snowmobiles affects your decision on whether or not to join an environmental club. You can't establish that cause-effect relationship, we'll see, without a good experimental design we'll get to later on in the class. So just kind of wrap up, you should be able to, at this point, make and interpret bar graphs for categorical data. Identify what makes some graphs of categorical data misleading, like those pictographs that are, or if your y-axis is poorly labeled or something like that, you have to make sure you're consistent with that. Calculate marginal and joint relative frequencies. So remember, marginal is like the total columns, joint is like the intersection of two. Calculate conditional relative frequencies. So that's where you'd say, oh, given that it's in this particular category, what proportion meet a conditional relative frequency, or even a whole conditional distribution. And then we can start to compare those conditional distributions for categorical data just by looking at percentages or, you know, with graphs. And so you describe the nature of that relationship between those. And there's not like a nice, simple way. You just kind of got to look at the different categories and compare and contrast and just describe that relationship well.